Hi, this video is on finding the volume using integration and the shell method. So if we look at this cylinder here, um, to find the volume of this cylinder, we're going to look at the entire cylinder as though it were filled in. The volume of this entire cylinder minus the volume of the hole, minus the volume of the hole. Um, we talk about the height of the cylinder. By the way, in this particular cylinder, the axis of revolution is the x-axis, the horizontal axis. Um, so the height is always going to be parallel. H is always going to be parallel to the axis of revolution. Here's the axis of revolution. Do you see how H is parallel to that? So H will always be parallel. The height will always be parallel to the axis of revolution. P is the distance between the axis of revolution and the center of our rectangle. So we're creating these rectangles that are always parallel to the axis of revolution. Your height and your rectangles that you're forming are always parallel to the axis of revolution. And once again, we're measuring the thickness. The W is the thickness of the actual cylinder. So here, W, if you look, W is the thickness of the axis of revolution. So when we do P, we go to the center of that thickness, and W plus 2, the width. I'm sorry, it's P plus W divided by 2. We go to the center of the thickness, so half of the width is the outer edge, and if you subtract the half of the width, then it's the inner edge. So that's what they're looking at when we derive the equation. So the outer radius is half of the width plus P, and the inner radius is half of the width subtracted from P. And they give you how they derive the formula. By the way, this is the actual formula we're going to be using. It's the volume of a cylinder. Once again, pi r squared times h. This is pi r squared times h. And if we do the math here, if you do the algebra here, this is what you end up with: 2 pi, the r, the h, and then the width, p, h, and w. If you do all the math, this is the formula that we get: 2 pi, the average radius, the height, and then the thickness of the cylinder. So if we look at the formula again, we have the height of the cylinder. We have the distance, P is the distance from the axis of revolution to the center of the rectangle. And we'll look at the two different formulas. If we rotate this around the horizontal axis, the x-axis, do you see our variable will be y? So if we rotate it around the x-axis, the horizontal axis, our variable will be y. Once again, we're rotating around the x-axis, so we're looking, and the variable is y. Since the variable is y, we're looking at the y to integrate. We're integrating the variable is y, we're looking at the y to integrate. Here, we're rotating around the vertical axis, the y-axis, so our variable is going to be x, and we're looking at the x to integrate, a and b. Over here, it's c and d. It's different here. And since we're rotating it around the x-axis for this problem, do you notice our rectangle is going to be parallel to our x-axis? If we rotate around the y-axis, the rectangle that we create, here's our P, from our axis to the center. Here's our P from the, once again, the rotating axis to the center of the rectangle that we're dealing with. So here's the first problem that we're going to take a look at. It says we're going to revolve this around the y-axis. If we're going to revolve it around the y-axis, x will be our variable. We're going to integrate this from 0 to 1. So when we integrate this, x is our variable, so we're going to integrate it from 0 to 1. There's going to be a 2 pi in front of it. And x is our variable, so we're going to do x and then times our height. And our height is always going to be the equation, right? No matter what x we pick, then we're going to find our height. If we find an x here, we'll find our height here. So it will be x minus x3. So this is the setup for this particular problem. If we look at it here, x times x minus x3, what they did was next distribute the x, and they get x squared and a negative x to the fourth. They just put the x to the fourth first when they distributed, right? When they distribute here, x times x is x squared. X times a negative x to the third is a negative x to the fourth. They just put the negative x to the fourth first. Then they integrated negative x to the fourth. You add 1 to the power, and then you bring the power down. The next one, x squared, is add 1 to the power, then you bring the power down. And this gets integrated from 0 to 1. So we integrated it, and now we're going to plug 0 and 1 in there. First, you plug 1 in there. You get negative 1 to the fifth is 1. And then you plug a 1 into here. 1 to the third is 1. Then you plug 0 in. And if you plug 0 in, you just get 0 for everything. So I'm left with negative 1/5 plus 1/3. This ends up common denominator 3/15 plus 5/15, which equals 2/15. And don't forget there's a 2 pi in front. So 2 pi times 2/15 ends up being 4 pi over 15, the answer that they get here. All right, so that's pretty fairly easy. If you looked at our picture, we're just dealing with one function and then this thing was going to be revolving around the y-axis. So you look at this shape, and it's revolving around the y-axis. Let's take a look at another problem. Oh, we just did this. I erased everything we were doing. Let's take a look at another problem. This is y equals the square root of x plus 20. So I want to draw this out first. Y equals the square root of x plus 20 is a graph. If you look at, you plug negative 20 in there, negative 20 plus 20 equals y 0. Do you see? If I plug negative 20 in there, this square root graph looks like this. And if you plug negative 21 in there, then you end up with a negative number, and you don't have a graph there. So that's what our graph here looks like, the square root graph. If you want to check that out, plug it into your graphing calculator and you can take a look at it. But we have another graph, y equals x, and y equals x is a straight line going through 0. And then we have one more restriction. Y has to equal 0. So y equals 0. y equals 0 is a horizontal line that goes through y 0. So let me draw all our three restrictions on our graph. We have three different functions here. And if you look, all these form this little shaded area here. So this is the shaded area. This is the graph that we're going to rotate, and we're going to rotate this graph about the x-axis. So just the shaded part that I put in here is what we're trying to find the volume of as it rotates about the x-axis. As it rotates about the x-axis. We're rotating it about the x-axis, so we're using the variable y. So this is different from the disk method. It's kind of like the opposite variable. So we're rotating around the x-axis. The variable we're using is y. And so we're going to integrate this on the y. Since we're using y, we're going to integrate it from y equals 0 to the highest y part. This is the highest y. I have to find out how high it goes. I want to find out the intersection of this line and this equation. I want to find the intersection of those two equations. So we're integrating. First we want to find out where those two cross. And once again, we're integrating with the y-axis. So I want to make y my variable. So I want to change this equation to x equals, the function x equals. So I'm going to square both sides. And I get y squared equals x plus 20. Do you see if I square a square root, they cancel. Then I'm going to take the 20 to the other side, minus 20 minus 20. And I get y squared minus 20 equals x. So now I have, this is my function. And this is my function. These are the two, once again, this is the function, and this is the function in respects to y. I'm going to set them equal to each other. Y equals y squared minus 20. I'll take the y over to the other side by subtracting y. And I end up with, y squared minus y minus 20 equals 0. Factor it out. And I get y minus 5 and y plus 4. So I get a y equals 5, and I get a y equals negative 4. Well, I know this spot up here is not negative 4, so it has to be 5. So we are going to integrate this from 0 to 5. Okay, so we're looking at the y values when we integrate, when we're rotating around the x value. So we are going to, this problem is going to be 2 times pi, integrating from 0 to 5. We're going to have y, which is our radius that we're looking at. And then we're going to have our function. So let's go back and take a look at our function. Now, normally, if we were rotating this around the y-axis, we looked at the x values, and we'll say it's the top function minus the bottom function, right? When you look at two functions, you want to find the area between. It would be the top minus the bottom. However, since we're rotating about the x-axis and we're looking at the y values, you almost have to take this graph and bring it upright. So take this whole graph and bring it upright. So if you look, this is the top of the function. If you look at it from the y perspective, and this graph is the bottom of the function. So it's going to be the top minus the bottom in respects to the y values. So the top of this function, y equals x, is y, minus the bottom of the function. And the bottom of the function, we already calculated it to be y squared minus 20 when we set it equal to, when we have y as a variable, y squared minus 20. So I'm going to distribute this negative sign first. I have y times y minus y squared plus 20. I just negative times a y squared is negative y squared. Negative times a negative is a positive 20. Now I'm going to distribute this y, and I get y squared minus y to the third plus 20y. And we're still integrating from 0 to 5 with a 2 pi in here. So let's integrate. Y squared changes to y to the third over 3. Y to the third, you add 1 to the power y4 over 4. And then 20y, you add, oh, that's not 20. Yeah, it is 20y. Add 1 to the power. There was a 1. Add 1 to the power 2 and divide it by 2. 2 pi. And we integrated that, and we're going to go from 0 to 5. So now I plug 5 into the function. I'm going to try to do it up here. I have the 2 pi. Plug 5 in there. Plug 5 into here. I get 125 over 3. Plug 5 into here. I get a minus 625 over 4. And plug 5 into there. 20 times 25 is 5,000. 20 times 25 is 5,000. Is 500. 20 times 25 is 500 divided by 2, and I get 250. Then if I plug 0 in, don't forget we have to subtract 0. You plug 0 in all that, you get 0. So this is my answer. So when I do all that math, I'm going to plug it in. 2 times 120. Let me do all the math inside. 125 divided by 3 minus 625 divided by 4 plus 250. And I change it to a fraction. I get 2 pi times 1625 over 12. So then if I cancel out the 2 and the 12, I get 1625 over 6 times pi. And that ends up becoming my volume. I hope this video helped. The shell method is a little tricky, especially when you're rotating around the x-axis, because you're dealing with the y variable. You almost have to take that graph and shift it counterclockwise a quarter of a turn, a quarter of a turn, and then you'll look at the top and the bottom of it. Let me know if this video did help.